Hello everyone. I'm trying to create a new video, this time around showcasing a bit of easy anti-cheat analysis. This video is not going to be, let's say, teaching video, but more of an informative one. You'll be required to have a bit of skill in order to reproduce what I'm about to show on screen, and at times I may move a bit faster than normal, and that's to reduce the amount of time in which I present everything in here. As I was mentioning in the post, I got a message on Discord from a user trying everything possible to get the game to work with the known methods for Ghost Recon Wildlands, as in using a command line in the clients, such as Steam or Uplay, depending which one you have, which version you have. So here for the game's properties in set launch options, if we type in -EAC underscore launcher and click OK, then we do the same in the command line arguments in Uplay -EAC underscore launcher. We click save. We minimize every client, and then we go to the game folder, into the easy anti-cheat folder, and then we swap the original file with the one that's mentioned in the post on Wemod. And then we run the game from either location here, here, which I just did, or the desktop shortcut, this one. The game should start. As you'll probably see, it'll work on my end, but some of the people have had not so great experiences with trying everything possible on their operating system. Windows 10 with the latest upgrade, I believe. It's like 2 a.m. right now. I'm going to mumble a bit, so I'm sorry for that. As you can see, everything runs on my end. Just close the game real quick. So, if we don't use the command line at all, so I removed it. As you can see, I don't have it here anymore. Then I'll do the same with Uplay. And then try to start the game. This is what's going to happen. Keep in mind we still have the DLL swapped, and then nothing in here is changed, so the original files. And I'm mentioning this because, well, there are some people out there who occasionally and almost every time attempt saying, well, we're not tempering any DRM, we're not modifying game files, blah blah blah. So I'm waiting for the game to start. The reason it takes a while to load is what you'll be seeing in a few minutes. There's a sequence of launch operations that happens considering I have both Steam and Uplay. Basically, I bought it off Steam, and Steam, what it does is to actually log you in through Uplay. So this is what's going to happen if you don't have the command line set up into the two clients. Well, basically you can only have it set up in Steam because, well, when Steam runs, it will pass on the parameter to Uplay, and this is going to be ping-ponged around till the game starts. But just to be safe, I recommended that you also add it into the Uplay client to the command line arguments that you've earlier seen. So this error shows up and it's a no-go. For some people, for example, if they do add the two command lines in the two clients and they try to start the game and they also have the DLL, what they receive is an error such as EAC not found. And I think I can trick the game into doing that exact same error if I do this. Let's see. The reason I rename the file. Rungame.exe is this is the actual EAC launcher. If you look at its properties and digital signatures, it says easy anti-cheat OI. And if you look through it at the string references, you'll find that this is the actual easy anti-cheat launcher. So nothing actually happens right now, and this is because, well, I've renamed this file. So that being said, what we want to try is to get the game to load without a command line, or at least with some command line that would skip. Oh, okay. Thank you, Steam. So with at least one command line that would skip all of the easy anti-cheat launcher and checks and stuff like that. So considering there are two clients that we have to deal with, and the executable that we have here will basically be spawned into a process. The process will be killed, then another process will be spawned, the process will be killed, and so on and so forth. The method I use is to open this up into debugger, such as x64dbg, head on to the entry point, and then here, instead of the original bytes, which are 48AD, I put in an EBFE. What this does is to generate an infinite loop, as you can see, jump to entry point at the file's entry point. Then I save this to disk. I'll have to save it differently, and that is because the current executable is in use. I'll rename the original one to BAK, and then I'll just use this one. So what we'll do at first is, if you remember those bytes 48AD, is we're going to run this, we're going to restore these bytes, and we'll go to create process API. Since I don't know which one will be used, I'll breakpoint both and press F9, and then this will happen. As you can see, following dump, and then hex ASCII, and then select everything in here, and then press Control E, and then go to string, and then not everything was copied. Weird. Okay, back here, Control E, string, copy. What the hell is wrong with you? Copy. I have no clue why this doesn't work. Okay, let's go up to here. Okay, well, anyway, since I cannot copy it, well, you'll just have to look at it. So what happens is Steam will actually, well, the game will actually launch the Ubisoft game launcher with these parameters: handle, the Uplay ID, game version, the path of where the actual executable is. I think this is in base64 encryption. Let's try and see if we can decode this. Decode. Well, since copy pasting doesn't actually work, let me see what else I can do. Maybe I can copy like this. Copy, paste. Well, like this it works for some odd reason. Or maybe just use it from here. Oh, there we go. View word wrap. And then let's take this. And then let's put it here and let's decode it. There you go. So what happens here is this equals this, and then working directory, which is also base 64, is going to be this one. Okay, so there you have it. So this is basically translated into run the Ubisoft game launcher with the game launcher weight handle 808. The game title is 3559. I believe you can Google this up and you'll see that you'll find Tom Clancy's Ghost Recon Wildlands. Version 1 of the game, the path where the executable is this one, as in this one. And then the working directory where you'll find the executable is this one, and that translates to this folder. And then you have UPC argument. Basically, if you had set up -EAC underscore launcher into the uplay command line argument, you would have seen it here. So at first, the Ubisoft launcher is being launched. Let's press F9 and see what happens. As you could have guessed, the process was killed. As you could have seen flashing here, the Uplay launcher was launched, and the actual Uplay launcher will launch the game based on the base 64 parameters that we have here. So now what we do, because we've set up an infinite loop at the executable's entry point, is we're going to attach to the actual process that the launcher spawned, this one. And then, since you see the debugger running, we'll press F12. But as you can see, the process doesn't pause, so we'll go to threads, main, and press F2 here, and you'll see the process stops. What we do now next is to replace the original bytes, if you recall that, and then we go to create process. We already have the breakpoint set, and we press F9 two times. As you can see, there's a gap here with win_http.dll. This is where we actually log into Uplay, and then this happens. Another process is about to be spawned, and this is the Steam process. Following dump, Control E. So right now, Uplay launches the game, and the game passes the authentication and then runs Steam. And I believe if you go to Steam and look for this value with this number of 6 digits, you'll find that it relates to Ghost Recon Wildlands as well. So let's let this run, and the process dies again. You've seen Steam in a flash earlier. And then, since we already have the infinite loop at executable's entry point, you can see another process was spawned. We attach to it, pause, and as you can see, pausing doesn't work again. Sometimes it works, sometimes it doesn't. Go to threads, main, F2 here, the loop stops for 8AD, and then we repeat the show. Now, as you can see, create process A is already hooked by Steam. You can see it goes into game overlay renderer. This is a DLL from Steam. Doesn't matter, we still have the breakpoint set up here. We do the same for create process W, and then we run. And what happens next is Steam is going to run following dump, and then we have this. So let me put it this way: number 1, number 2, number 3, and as you can see, it's the same path highlighted, the same path highlighted, And then we have arguments here, and these are the arguments. And let's decode that. And then we have the decode, and the decode does this. And this is what this base64 string means. You play Steam mode, so it's put one time in base64. I believe maybe this is used for something like logging on or handshaking or stuff like that, and then in plain text, as you can see it here. So with that in mind, cancel F9. Again, the process dies, and then another process is spawned. Pausing doesn't work this time around, so go to main, F2, Control E, 48AD, and then we want to check the same breakpoints and run. Again, pause, so this time around we're logging into Steam. Actually, we're logging back into Uplay as well, I think. And then we have this. And as you can see here, what happens next is this is going to be run. So number 4 is this one. So run game, which is the easy anti-cheat launcher, is going to be started, and it's going to be started by the Ubisoft game launcher. And then I hit run. So at this point in time, considering, yeah, there you go. So at this point in time, considering that we've run the GRW executable 4 times around, and that the last process 1 time, 2 times, 3 times, yeah, 3 times, and then the run game actually runs. And what run game does, which is the easy anti-cheat launcher, is to verify the file integrity. GRW EXE. If you remember, I patched the entry point with basically 2 bytes there, EBFE. So of course the file hash has changed, and of course the easy anti-cheat launcher has a feature that basically checks if the file has been modified or not. So this is the error that I get right now, and what we want to do is progress further past this error and see what's going on. Basically see where exactly rungame.exe is actually running our game, grw.exe, the 4th time. I click OK, and well, you can see here, launch error, unrecognized game client cannot continue. And this is also how I know run game is the easy anti-cheat launcher. So exit, and what we want to do next is drop this into the debugger, and as you can see, the process cannot be opened into the x64 version of x64dbg, and that is because if we open it with this one, you'll see that we're in x32dbg, which is the, you see here, push ebp, move ebp, sp, push 0, stuff like that, and this is the x86 version of x64dbg. So rungame.exe is a 32-bit executable. So what we want to do is apply the same mechanism here. So Control E, remember those bytes, E8, E7. So put EBFE, click OK, patch the file, and choose this one, do it like this, and then close the file, and then rename this one to BAK, put this back to EXE, and then let's try one more time. Okay, 48AD, actually, my bad, 48AD, run, okay, first process, main thread, stop, run, and now we wait for the login. Second process, attach, pause. As you can see now, the F12 key worked. 48AD, run. Third process, attach, pause. Pause doesn't work. Main F2, 48AD. And what's going to happen now is a run game is going to be executed, but since we put an infinite loop at the executable's entry point, so this process dies, but now the launcher doesn't start anymore. So what we want to do now is use the x86 version of x64dbg. See x64dbg x32, this one, and then attach to run game, which you can find here. F12 again doesn't run, so threads main F2, and if you remember, the bytes were E8 E7 this time around. So what we want to do from this point onward is basically walk through this executable, stopping at certain points in time and making annotations, or just setting breakpoints for future runs. So this next step in what I'm presenting is pretty much going to be something that I don't explain that much. You'll just see me running around. So I'm passing the first call because I know this is an initialization call. Go into the jump, and then somewhere in here I should find the winMain function. And since the code doesn't resemble any Microsoft Visual C++ version that I know of, I'll just run with F8 up to a certain point where I'll stop and check the calls, for example, just to see what's going on inside. If there's any extensive run-up stuff that's happening. I think this one stops here actually. No, actually here. I'm going to pass this one, get startup information W, and then I also see here the command line with which the executable is run. So this is basically the spot where the command line is parsed. Control F9 to get the return to the return point. And then, oh yeah, so maybe it's in here. Yep, this is where the magic happens. Easy anti-cheat launcher. So push, set a breakpoint here, and one here, maybe when I press F9, yeah. So I'm still in here, no error. And then I'll go in here, and we'll see what happens. And I run some functions, update window, get message, translate message, dispatch message, app icon, main window registration failed, show window, failed to create window context for logo animation, updating contents, scroll, 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 hidden left, bottom right, stuff like that. I'm trying to find something representative to stop at, but then again, maybe the functions aren't that continuous as I thought. Okay, so let's just run through this. Get message W, dispatch message, and then this is get message. Okay, and then translate message and dispatch message. And the message is, well, there's a message, not a function. Okay. I remember correctly, when I did this, yeah, debugger has been detected. So if I remember correctly, what the loader does is to actually load the x86 version of the DLL, as in this one here. And this one here has that particular message with debugger detected. Search for current module, string references. Well, memory map, ASCII, tire block, debugger present, debugger present, debugger present, debugger present. Okay, debugger. I know there is a message somewhere because I found it. Okay, so what we'll do is to track back all the way outside of this function and stop where it says entering background, wait for the game process to exit, wait for single object, and then okay. So I believe this was a function that does the initialization. So I'll set a breakpoint here, here, scroll a bit, initialize main window failed. I think I passed through this, then through this, finished window initialization. There was something here with a set timer, if I remember correctly, and then this is basically the window process, Windows callback loop. Solid brush, release capture, easy anti-cheat, create directory, free library, and I think this is the exit part. And then identifier message launch cancelled, and in here, if I remember correctly, there is as I was saying in the beginning, I did this previously to recording the actual video, so I kind of know what I'm looking for and looking at. I just need to find, there is a dynamic jump that takes into account a certain parameter. And this is also where we will see the debugger found message. Cancel requested by user. Okay, command line W. Where are you? Where are you? So much for gaining time. Okay, processing command line. Working directory path. Damn it. Somewhere close by. I'll go back up. In case you're wondering how I got to those locations, well, I did trace every function and drew some conclusions about it. Launcher finished. Sync resolve message. Just so you know, what Easy Anti-Cheat does is to determine the type of operating system that you're on, and then it downloads an encrypted payload, then decrypts that payload, and that payload is actually a driver, and the driver is then initialized, a service is created for it, the name of the driver has something related to Wildlands in the naming convention, then the driver starts, and based on the certain driver function, the debugger that we're actually in right now is detected, and that's why we get that error in user mode. But I don't remember exactly where the damned jump was. So I'll just track back to this location here and resume afterwards. So I'm killing the process and I'm retrying this again. F2, 48AD. Yeah, it's tiresome, but we'll get results in a sec. Threads, main, F2, 48AD. Now we have to wait for the login. Second process, attach 48AD. And then here, then threads, main thread, then logging in, and then attach and process died, and then refresh, and then run game, then threads, main, pause, E87, and then F9. So we get to this point here where I set up the breakpoint, and F8, then past this. Okay, so this is basically where the initialization is. Okay. Damn you, what's going on in here? Roboto, failed to load embedded font. Localization logo, window, create window, blah blah blah. Metrics for positioning of the window. Okay, back, and then okay. So splash screen initialization didn't fail. Work directory information query didn't fail. And then again localization load. And then we have this, and then the settings. This is where the settings are being read. Settings file path. So we'll stop here, and then I believe this is where the actual window is created. Register window classes, and then create window, blah blah. Okay. Okay. What next? Progress bar. So creation of various stuff. Okay, get window rect. The exit button. Okay. I believe this is where the actual create game launcher function and interface is being executed from the x86 DLL. Failed to create iGame launcher instance, and this is where the function ends. So boom, and I believe right now we have the x86 DLL launched, and then we have this executable path. Okay, and finish window initialization. Okay, set timer. Alright, and then we get out of this. Man, it's not cool. Okay, I remember this. Update tracked. Ah, come on, man. Memory map. Symbols. Easy anti-cheat. Following this assembler. Search for current module string references. Downgrade detected. Failed to determine username. Crypt. Yeah, I don't remember anymore where this error comes from. Launch error, maybe. Launch error. DNS. File not found. Success loaded. Cancel. Success loaded. Download success. Small launch. Game launcher. Well, one more time. 48AD. Attach. 48AD. Okay. Second, attach. Threads. 48AD. Run. Third process, attach. 48AD. Then run game and attach. Alright, refresh, attach, 87, run here, and then here, and then here, here. And then we have this as in easy anti-cheat, Control F9, and I'll just continue from here. You can see what's going on in the background. As well, the actual error is going to happen somewhere in there. Finish window initialization, set timer. And then entering background blah blah, and then hopefully, there we go, download success. Have an error already in there. As I was saying, something gets downloaded, and where it's downloaded from is this location. I believe this is location. Location, location, location. So if you try this link later on, and you just want to see what EAC actually downloads, you'll find that It's a payload of about 2 megabytes big. And download success, scrolling proxy, launcher, and this is where it ends. And then we exit this, then hopefully scrolling up. Callback message, connection failed, CDN path overridden by local config file. No, it's outside of this. So this is where the actual cleanup happens after the download. And then there's this callback, and then no. I so hoped that this video would be short, but apparently it's going to take a bit for me to figure out again what I did. Okay, then I'll see who calls this one more time. So while trying to make this short, I actually made it longer. I think it's half an hour right now into this video. Attach threads main attach. So as you can see, the reverser work is not that easy to do, and it takes time, quite a lot of time in some occasions. And of course, when you post stuff online and then some fuckwad comes into play and makes fun of your work, of course you're pissed, because right now it's 30 minutes in and I don't remember exactly what I did in the past, so okay, those breakpoints are fine. Threads main 87 run. We're here, splash screen. So what I'm actually going to do is go to symbols. This one wasn't loaded yet, so load library A, load library W. This is where I'm going to trap you. Easy anti-cheat x86. Library was loaded. Run game, get proc address of create game launcher. And this is the function. Follow in disassembler. Well, I already had this one. Create third-party launcher. Create HTTPS client. Initialize. Destroy. P2P. Blah blah blah. Poll. Validate. I don't think I need all of them. Begin frame, end frame, game round start. As you can see, some of the functions Cerberus in easy anti-cheat. Player revive, player tick. Interesting. This is the first time I'm seeing this. Player take damage. Client health initialized. Initialize. I think, yeah, this is the one. I found the function. Yay. So this is the actual dynamic jump that I was talking about, and here what this has to do is to jump exactly, I think, in this location. Oh, it's actually something similar to this, because there was a bigger call down the line. So what I'm going to do is I'm just going to do a search for FF for 0F B680, and then 1, 2, 3, 4. I'm looking at this MOV ZX EAX, and then FF24 85, and then I'll just copy this just to use it later on. Okay, so found several. Now I have to remember that right one that I need. Okay, this is the one. So this is basically down below this MOV and jump. This section here is the section that's actually running the game process. Well, I already had the error here, but I didn't properly look up top. I did put the breakpoint, but I didn't check above it. So I'll just break here. I'll run this. Blah, 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 blah. I'm removing the breakpoints. Blah, blah, and then I'm here. So as you can see, it's 03. It jumps to this location. So if I jump with 03 here, what you'll see now is in here the code that actually detected me. Let's see. Finished window initialization. No, it's not this one. But this function is ran multiple times. Okay. Then still 03. Okay. Then this is where when HTTP is loaded. Okay. Okay. What I know is the error function happens. I think here. This is where the error occurs. Let's see. The bugger has been detected. There we go. So instead of jumping to EAX multiplied by 4 plus this value here, EAX being 1, which leads us to, yeah, I was close. So it's up top here instead of here. So this is basically the exit function. So what we want to do is change the offset in EAX. Don't ask me how I know this is an offset, to 0 in such a way that now the jump leads to this location. And then you'll see that if I go to create process A and create process W, run game will try to following dump. We'll try to run the game. We'll actually run the game with this command. So number 5 is this. Now, the reason I'm showing you this, and the reason I wanted to get here, is to actually show you how well the game does run. So run game.exe exited, and now what we have to do, considering we have that infinite loop on the grw exe put in place, we have to attach to it. You see the process has been created. Attach threads, main thread f2 48AD, and once we do the resume, and we wait a bit because we in HTTP, so this is the second login, and there we go. Ta-da! So I killed it. Now, all of this demonstration, the conclusion of it is as follows. As long as you keep the DLL in this format here, the 3 kilobytes one, the one that contains the detoured export functions, and then you either keep this run game.exe here or you rename it. Let me just delete or just keep it here, ebfe, and put in place the original one, and then restore the original one. So everything is back in place. We have the original 2 game executables, then we have easy anti-cheat, and then this is the original one. This is the one that we replaced the original with. So back to this text file. If you look at this command line -eac-nop-loaded and look for it online, you'll see that for some games like Dragon Ball Z and Dead by Daylight or something like that, people have used this command line to actually bypass EAC loading in such a way that they could play the single player part of the games with cheats. That's what they were interested in. Removing or bypassing EAC will not work with multiplayer, or cooperative modes, so don't even attempt or even think about asking for that. But the conclusion that I wanted to get to after all of this demonstration is you can take this command line, go into Steam, set launch options, paste it here, click OK, close, then run the game from whichever location you want. You can even rename this in such a way that it will never run and just run the game. And what that command line will do is, if you debug the game again and track down the command line, you'll see that it skips altogether the running of the Easy Anti-Cheat launcher. So there won't be any checks against your executable if you modify it in any way. There won't be any checks related to the Easy Anti-Cheat files. As you can see, everything runs normally on my end. So that's about it for this demo. Conclusion is basically this. So with this command line in place, I'm basically demonstrating how not bitching about command line that was long been used can help in many ways if you just invest some time into actually analyzing a protection and not complaining with each occasion that you don't have the time to do this and that, but yet you write a ton of text in a post on a forum. That being said, thanks for watching and hopefully we'll see each other next time. Bye bye.